the last couple of recordings illustrate a factor. In the first one, we had an object whose mass distribution looked like this, and we were trying to spin it, to rotate it about its center. The girls were trying to swing it about the center. And we compared that to an equal mass object where the masses, the extra mass was closer to the center. And we found out that it's much more difficult to get this to rotate than this one. Even though they have the same mass, it's more difficult to rotate this one. In the second recording, we saw that when we had an object that we were trying to balance, essentially having it remain in the same state of motion or preventing it from flipping, by flipping, it's going to actually spin about the point of contact, the point we hold it. So if we would like to prevent it from rotating, we saw that it's easier to prevent a longer object than a shorter object from rotating. Even more, we notice then when we added a mass to the end of the object, the end that's further away, it was even easier to balance. Easier to balance, it means it was more difficult to change its state of rotational motion. So, in other words, what this tells us, to change the state of rotational motion of an object, mass is not the only factor. What's going to matter in this case is the way we distribute the mass relative to the point about which we want to rotate the object. Now, since here we are talking of the ability to change the state of motion of an object, that leads us to think of the word inertia. Inertia, in the case of linear motion, we just explained it as mass. Mass makes it, the more mass an object has, the more difficult to change its state of motion. Now, in this case, the more mass and the way the mass is distributed, the more difficult to change the state of rotational motion of an object. So in other words, we have to introduce another quantity, a new quantity, that we call rotational inertia. The term that most people use is moment of inertia. The engineering term is moment of inertia. But the more intuitive term would be rotational inertia. So the rotational inertia of an object is a quantity that specifies how easy or how difficult it is to change the state of rotational motion of an object. From the videos we have looked at, we can deduce that the larger the mass of an object, the harder it is to get it to rotate, very much like linear motion. However, we also found out the further away the mass is from the axis of rotation, the harder it is to get it to change its state of rotation. So actually, we have two things that come into play: the actual mass of the object, and then also how far is that mass from the axis of rotation. One thing that's interesting which is a result from what we just have said. When we get to rotate an object, the axis of rotation that we choose is going to determine its rotational inertia. For example, if I have an object like this, rotating it about an axis here is different than rotating it about an axis here, and different than rotating it about an axis here. All of these have different rotational inertias. So in this case, I talked about 3. For any object, you have an infinite number of rotational inertia.